everyone. Welcome to the classroom of Power Grid Dispatching Operation. Previously, we have learned about the normal operation of the bus. Next, we will learn about the normal operation of the line. I will explain it to you from 4 aspects: the 4 operating states of the line, the operational principles of line shutdown and restoration, the operational methods of line shutdown, and the operational methods of line restoration. The power line is a very important primary equipment in the power system network, which is divided into the overhead line and the cable line according to structure, responsible for transmitting and distributing electrical energy. There are many lines in the power system, and the force is relatively high. Therefore, the operation of the line is relatively frequent and important. The operation of the line involves the state change, and the line has 4 states. State: operational state, hot standby state, cold standby state, and maintenance state. The operating states refers to at least one side of the line breaker being in the closed position and the line carrying operating voltage. The hot standby state refers to having at least one switch on either side in the hot standby state, with switches on each side in the disconnected position. The cold standby state means that the switch on each side of the line and the related grounding switch are in the open position. The maintenance state refers to the opening of knife switch of the line and the knife switch on the side with high resistance and high voltage of the line, and the grounding switch is closed or the grounding wire is hung up at the outlet end of the line. The principle that must be followed for power outage or transmission operation on the line is that for the power outage of the terminal direct feeder, stopped the receiving end first and then stopped the transmitting end. The order of power transmission is reversed. For a power outage on a single contact line, the side with a smaller power capacity is usually stopped first, and then the side with a larger power capacity is stopped. The order of power transmission is reversed. For any power outage in a double circuit parallel line, the power plant side is usually stopped first, followed by the system side, and the power transmission sequence is reversed. Next, we will give examples to introduce these 3 situations separately. Power outage to the terminal direct feeder as shown in the figure. The power outage sequence is as follows. Step 1. The receiving end should first cut off the load or reverse the load to other lines, so that the line can be equipped with a single no-load transformer. Step 2. Consider the neutral point of the transformer to avoid overvoltage during operation. Step 3. Open the K2 circuit breaker and cut power on the receiving end first. Step 4. Open the K1 circuit breaker and then stop power on the power supply end. The order of power transmission is reversed. Step 1. Close the K1 circuit breaker and transmit power to the power supply end first. Step 2. Close K2 circuit breaker and then transmit power to the receiving end. Consider the grounding of the neutral point of the main transformer. The power outage of the single circuit tie line as shown in the figure. The order of power outage. Step 1. Open the K2 circuit breaker and cut power on the side with smaller power capacity first. Step 2. After opening the K1 circuit breaker, cut power on the side with a larger power capacity. The order of power transmission is reversed. Step 1. Close the K1 circuit breaker and transmit power to the side with the larger capacity first. Step 2. Simultaneously parallel at K2 circuit breaker with the side with a smaller power supply capacity being transmitted power. Power outage for any of the lines in the double circuit parallel line as shown in the figure. The order of power outage as follows. Step 1. Pull the KE circuit breaker at the transmitting end and cut power on the plant side first. Step 2. Pull the K2 circuit breaker at the receiving end and cut power on the system side. The power of transmission is reversed. Step 1. Close the K2 circuit breaker at the receiving end and transmit power to the system side first. Step 2. Close the K1 circuit breaker at the transmitting end and transmit power to the power plant side. After understanding the principles of line operation, let's take a look at the operation methods for power outage and power transmission on the line separately. The power methods of power outage. Firstly, before the operation of power outage, the power flow should be adjusted, and the relevant protection and safety automatic devices should be adjusted. The method is as follows. Point 1. When the line is in a power failure, consideration should be given to whether the station is a suitable disconnection point or decoupling point for the line, and consideration should be given to reducing system voltage fluctuations. If necessary, voltage flow should be adjusted. For the feeder line, the circuit breaker at the receiving end should be opened first, and then the circuit breaker at the transmitting end should be opened. Point 2. When one of the dual circuit power supply lines experience a power outage, the load condition of one of the two lines should be checked to prevent the user from experiencing a power outage due to the shutdown of one line and the opening of the circuit breaker of the other line, or the overload of the other line caused by the power outage of one line. Point 3. If the power outage of the line involves changes in safety automatic devices, relevant regulations should be followed. Point 4. When operating a power outage on the line, the equipment should be stopped first, and then the automatic protection device should be stopped. Secondly, when the line is in a power outage, attention should be paid to the operating sequence of the circuit breaker and the disconnector, because Step 1. Open the circuit breaker on each side of the line. Step 2. First, open the disconnector on the line side, and then open the disconnector on the bus side. This is because even if an unexpected situation occurs, or the circuit breaker is not actually disconnected, causing the disconnector to be pulled and closed on the load, the fault point caused by it always remains on the load side of our circuit breaker. Thus can be cut off by the protection action of the circuit breaker, minimizing the impact of the accident. On the contrary, if the fault point occurs at the disconnector on the bus side, it will cause a complete power outage of the entire bus, expanding the power outage range. Step 3. Open the grounding switch or hanging earthing wire on each side where there may be a power core. It should be noted that when a power outage occurs on a 3/2 switching scheme, the middle side circuit breaker is usually disconnected first, followed by the bus side circuit breaker, then the line side isolation switch. The operation methods for power transmission on the line also include 4 aspects. The first aspect, the selection of the charging end. During the operation of power transmission, if one side is the power plant and another is the substation, power is generally transmitted on the substation side, and the loop is closed on the power plant side. If both sides are substations or power plants, the loop is usually closed from the side with large capacity and strong connection to the site with small capacity and a weak connection, except for special regulations. The second aspect, a constrained condition for line power transmission. Point 1. Before charging, all safety measures, including switches on both sides on the line, have been removed. Personnel have been evacuated from the work site, and the power transmission conditions are in place. Point 2. The switch of the charging line must have complete relay protection. The third aspect, adjustment of relevant protection and safety automatic devices. Point 1. When the first line is powered on, the automatic protection device should be put into operation first, and then the primary equipment should be put into operation. When the line is transmitted and there is no automatic locking reclosing, and the reclosing must be deactivated. Point 3. For the first power transmission of a new line, in order to prevent misoperation of the protection device caused by wiring errors, high-frequency protection, impedance protection, differential protection, and other directional protection must be charged on the line and subjected to the loaded testing to prove that the protection fully meets the requirements and the direction is correct before it can be put into operation. Point 4. If the power transmission of the line involves change to safety automatic devices, relevant regulations should be followed. The 4 aspects: operation sequence of the circuit breaker and the disconnector. The first step is to open the grounding disconnectors at each end of the circuit. The second step is to first close the busbar side isolation switch, and then close the line side isolation switch. The third step is to close the circuit breaker when supplying power to the 3/2 switching scheme. The bus side disconnector is usually closed first, then the line side disconnector is closed, then the bus side circuit breaker is closed, and finally the middle circuit breaker is closed. Finally, let's sum up and think about it. What's the operational sequence of line power outage or transmission? What precautions should be paid to during the operation of power outage or transmission on the line? That's all for today's lesson. Thank you.